today, we will be covering the different methods on how to solve first-order differential equations. There are different methods on how to find the general solution of a first-order differential equation. One of which would be the methods for separable equation. But before we will be dealing with those various methods, so let's try to determine first, so what are we trying to achieve at the end of this presentation. So the first one is that the student should be able to identify so whether a given first order differential equation is separable or not. And next, once the student was able to identify so whether the equation is separable or not, so the student should be able to determine or find the general or particular solution of the first order differential equation using separable equation. So out of the different methods, so how do we differentiate separable equation from the other? So separable equation is very specific. So it is a first order differential equation, so which has a standard format, and its format would be dy over dx would be equal to the product of the function g of x, so multiplied it with the function h of y, and that is said to be separable or to have separable variables. As long as a given differential equation would have this format, so wherein the differential dy over dx is equal to the product of two different functions. So one function would be a function of x, and the other function would be a function of y. Therefore, that kind of differential equation can then be resolved using methods for separable equations. But again, before we deal with the details on how to solve separable equation, let's try to cover first the different application of separable equation. Where do we actually use this kind of method? So in various applications, so such as the spread of the virus, so separable equations or methods for separable equations can be used. Like, for example, the spread of a virus can be mathematically modeled using differential equation, and the differential equations that can come out based from the spread of the virus can be resolved using methods of separable equations. Like, for example, at a certain period of time, this number of people got infected with this virus, and then using the mathematical model for the spread of the virus, we'll be able to determine that if there are no intervention that will take place to combat such virus, then at another period of time or at a later period of time, so we'll be able to predict so how many people will be infected by such virus. So other applications can be used as well in terms of money. So if we want to determine the amount of money that we will earn after a certain period of time, like for example, if we are going to deposit a certain amount of money to the bank, and then with this certain interest rate, so using the differential equation, so we'll be able to determine how much money or how much profit can we take, so based from the interest rate that was given for us by the bank. So those are some of the applications of separable equation, so which we will be dealing with. So once we proceed with the topics pertaining to applications of first order differential equation. So by the way, there are different ways on how to determine so whether a given differential equation or not. So sometimes the problem is not on solving the differential equation, but rather on how do we really identify so whether a given differential equation is separable or not. So the first thing first is usually the separable equations are the easiest differential equation to be noticed. It's because just merely looking at the differential equation, we could rightly spot on that there is a product of two functions, the function of x and the function of y. So in such cases, so separable equation would always be the first method to be used in those cases. However, not all differential equations can be easily determined or can easily be separated. So there are cases that even looking at the differential equation, so it would be very difficult to separate x from y. However, through factoring, we'll be able to separate the value of x and y. So in short, before we can separate the function of x from the function of y, so we need to perform factoring first. And after doing such method, so that is the time that we will be able to separate one from the other. So to give you an example, so let's have this type of differential equation. So it's a first order differential equation wherein dy over dx is equals to y squared x cubed e raised to 3x plus 2y. So this one is a separable equation because as you can see here, there is a product of two functions, the function of x and the function of y. However, for the exponential function, so there is a combination of x and y. But through the use of properties in algebra, so we can rewrite that dy over dx is equal to y squared x cubed e raised to 3x multiplied it with e raised to 2y. So as you can see here, so there would be a product of two different functions. So the x functions would be the x cubed e raised to 3x, while the y function would be the y squared multiplied it with e raised to 2y. And from here, if we will be multiplying the equation by dx and then dividing the whole equation by y squared e raised to 2y, so we'll be able to get the value or the equation to be transformed into dy over y squared e raised to 2y, and that would be equal to x cubed e raised to 3x multiply it with dx. And as you can see on the transformed equation, so we were able to separate the value or all y's on the left hand side of the equation and all x on the right hand side of the given equation. So in such case, therefore, that is a separable equation. So there are cases that it would be difficult to separate a given differential equation, or it is not really possible to separate such equation. For example, this one, we have dy over dx, which is equal to y plus sine x. So usually if we want that all y's to be on the left hand side and all x to be on the right hand side, so we will be subtracting y on the left hand side as well as subtracting y on the right hand side of the equation as well. So in such case, so we will be having dy over dx minus y is equal to sine of x. So in this case, the one on the right side is a function of x. However, the one on the left-hand side of the equation is both still a function of y and x. And if we want to remove dx on the left-hand side, so we could multiply the whole equation by dx again. So yielding to dy minus y dx is equals to sine x dx. So as you can see here, the one on the right side, everything is a function of x, and the one on the left hand side is the one that we are having a problem with. So we cannot remove dx on the left hand side, so making this one as a differential equation which cannot be resolved using separable equation. Okay, so those are the examples on how to determine whether a given differential equation is separable or not.